Welcome to another tutorial on MATLAB Tech for Autosar. Till this point, what we have discussed is like why to use Autosar. So coming to the same, so there are some key principles based on which Autosar is being developed, and the problem that it solves over the years is a good challenge that happens in the automobile industry. So in this particular video, we will see like how these challenges are being solved and what are basically these challenges in actual field. When you develop a actual vehicle software, then what the challenges that comes into picture and how Autosar helps to mitigate the same. So to understand all these basic concepts, please stay till the end of the video so that you will get the realistic problem statement, along with that how you can use Autosar to solve the same. So consider you have three manufacturers who are trying to develop some module. You can consider a BMS module. They are trying to develop some BMS algorithm, maybe for SOC estimation. You want to do some algorithm creation or some software creation so that you can improve your life of the battery by giving the user the optimized way of SOC that is there in the battery. So in this case, we have three manufacturers. First is Porsche, next is Mercedes, and next is BMW. And they have their different car lines. And they cannot develop the software because they have limited time now. So how they will solve this problem? So they can solve this problem with the help of some external vendor. So they have two options in this case. One could be Bosch and another could be Continental. So in this case, maybe some of the manufacturer will select Bosch and some of the manufacturer will select Continental. So for one SOC determination algorithm, there could be multiple components of software that they need to develop. If these softwares are not compatible with each other, whatever Bosch and Continental are developing, along with the softwares that are there already present in the ECU of the vehicles, then it will be a big challenge to implement all these developed software from Bosch side, right? Or from Continental side. So those problems are very big in nature, which is also time consuming, because to develop the software it takes a lot of time. Along with that, to integrate it will also take a lot of time, and at the end you get the product. So like it is a 1 year or 2 year deadline that you need to manage. So how you can manage all this? So you can manage all this with the help of the Autosar, because it solves many problems. This is one set of problem that you are able to see, but Autosar in total solves 4 to 5 major problems that comes into picture. So in this case, we will go through individual conceptual problem that we have, and we will try to see a use case based on individual problem that it solves, so that it will be more easy for you to understand what basically Autosar solves, and in which case Autosar will be useful, and how you will be able to solve real world problems with the help of Autosar. So the first problem Autosar solves is reusability, right? So if you consider a software that you developed, consider a battery management software which determines the SOC in this case, and you have developed the same software, but you have many vendors that are waiting, like we mentioned, right? We have three car manufacturers and they want a BMS algorithm. Now you are developing but you need to also optimize your time. So in that case, what you can do, you develop the BMS software for overall one package, and that you can use it for all the variants. So one BMS software will be used for variant 1, variant 2, and variant 3. So that way you can update the same code inside these vehicles, but with help of some control. Maybe you have developed 4 features, and out of which you want to activate only 2, or you have developed 4 features, then you want to activate only 3. So that is done with the help of variant coding, and with the help of the variant coding concept, you can update software, same software, but with different behavior in different vehicles. So this is a concept of reusability that Autosar gives. So basically you develop one software and then you use it for all the vehicles that you have. So this is the basic case of reusability in case of Autosar. So same software you use for multiple cars. Next is time for the integration. So what is basically time for the integration means? So you will develop one software component, and then you will develop the next software component. Then you will develop the another software component. And at the end, what you will do, you try to integrate all these, because these will be running in one ECU. So suppose you are developing an inverter ECU in this case, then inverter ECU will get a request like, I want to generate this much output. So based on that, there should be a control signal that gets generated, right? So that feature may be the control inverter control functionality is developed in one software component, which could be this one, right? And now to operate the same inverter, you may request some voltage, or you may request some current from the battery, right? So for that, it needs to communicate with the BMS module, right? So one software component that you developed in the same ECU for that particular functionality. So now you integrated both of them, and you are able to see like both are integratable. So this is only possible when you use the Autosar framework. So Autosar offers a concept called RTE, and through which you can integrate many software components together. Even if you want to communicate between the ECUs, it will also do the communication with the help of this RTE and base layer that we will see later on. But the architecture solves this issue of integration time. So here in this case, to integrate both the software, it will take very less time, because you will have defined interface, and because of that, it will be very easy to do the integration process if you have followed the Autosar architecture. Next is the rigidity of the software. So if you consider rigidity of the software, it is somehow similar to restricting the software for updates. So time to time software update is always needed. So suppose you are driving a vehicle and you found something like an issue in the SOC module. The vehicle is not telling you the right SOC whenever you are turning on the car and then turning off the car and again turning on the car, the SOC gets changed. So in this case, like, it is not a good behavior for the customer, right? So there could be a debugging team or function group team who can analyze all this. Now they found that there is problem in the SOC calculation algorithm and there is some update needed. So what they decide, there should be a change in the code. Now there is a change in the code, and where I want to update the real time code that is running on the vehicle now. So that is only possible if your software is flexible for changes, right? So if there is very restricted, like a suppose for example, you can consider a hard coded program and a soft coded program. So in hard coded program you have defined like some variable will have some constant value. So in that case you cannot change that, but that variable, it takes output from another variable, then you can change it and update it. So rigidity means if you want to update your software over time, then it should allow the software to update. So that feature is also offered, and this particular rigidity problem is also solved with the help of Autosar. The next problem it solves is complex supply chain. So suppose you have developed a complex software. Now to validate this particular software and to decide like whether the software development is complete and the software is bug free, it is very difficult. So Autosar provides a good framework which tells like the complexity can be this much, and you cannot go more complex than this. If you want to develop a complex software, then in that case you just divide it into multiple groups, so that it will be very easy to do test. And once you develop all these softwares, definitely you need to integrate it into the ECU, right? So when you do integrate it into the ECU, then in that case there will be a integration time involved. Along with that, there will be a validation time involved. So all these process makes the entire software lifecycle bit complex and also long. So the more complex the software supply chain is, the more complex will be the development process. So if you follow the Autosar architecture, then in that case, Autosar offers the simplification methodology through which you can develop a complex software, and it solves the complexity. As we seen, like in the integration time, it takes a little less time because you will have interface defined. So same way it happens. Next is time to market. So suppose you develop the software and new functionalities are being added. Now what you can do, you can send it as an update to the vehicle, and then the vehicle will get updated with the latest software so that the customer can use it. And once they use it, you will get some feedback, and again you will redevelop or update the software. So the time to market is the major problem that Autosar solves. So these are the 5 major problems that Autosar solves. In the coming tutorial, we will be looking into what are the different layers of the Autosar and how they are being developed, and what is basically different components that are present in the layers of the Autosar. And then we will jump deeper into the same, and we will try to correlate all these 5 concepts to that particular in software architecture, so that it will be more clear for you to understand how you are solving all these problems. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you.